Hi, in this video, the second video of this series is going to be talking about rational exponents and properties of radicals and how do I simplify an expression that has variables whenever I'm combining two separate square roots together. And see, the nice thing is this, is I'm going to show you an example that deals with numbers real quick, okay? What if I had, say, the square root of 16 times the square root of 25? What would I have? Okay, and most of you could probably tell me that the square root of 16 is 4 and the square root of 25 is 5, and so 4 times 5 would be 20, right? Well, it turns out that if I wanted to, remember, I could recombine, when it's all multiplication division, I can recombine into one square root, and I could take 16, whoa, let's clear all that junk off. 16 times 25 is 400, okay? So I could call that, if I wanted to, the square root of 400. And on my calculator, if I do the square root of 400, I get 20. So there's another way to think about it, right? I can combine simply by multiplying the stuff inside of the square root and forming one giant square root. That might help me out here. And so what we're going to do is we're going to have two square root signs in this problem with x's and y's and z's, and we're just going to simply multiply those values together under one square root sign. You can do that as long as there's no addition or subtraction going on inside. That is totally separate example. We'll get to that here in about next week sometime. Okay? So with that idea in mind, let's take a look at this. Okay? I'm going to put this all under one square root sign. Okay? Not written, right? And there's not a cube or a fourth root, so that's a square root. I have x squared and I have x cubed over here. And so if you remember our properties of exponents, if I multiply x squared times x cubed, I have 2 x's and 3 more x's. That gives me a grand total of 5 x's, right? So that becomes x to the 5th. As far as y's go, I don't have any y's in the second expression, only in the first one, so it just remains y to the 5th. That's easy enough. For z's, I have 3 z's over here and 5 z's over here. If I multiply those all together, it gives me 8 z's, so I'm going to write it z to the 8th power. And so really, this is the same expression. Now, it's how do I deal with this? And so using whatever method you want to from the first video, okay, what I know is this. For instance, I could write x to the 5th. I know that I can pull out 2 separate pairs of x squareds, right? Because really, x to the 5th is x squared times another x squared times an x. Okay? That's the same thing that we had last time. Y to the 5th, I can write as y squared times y. Okay? So I could pull 2 separate pairs of y squareds out of this, right? And z to the 8th is awesome because z to the 8th is really z squared times z squared times z squared times z squared. Okay, I've got 8 z's all together. And so when I look at what I can actually pull out of the square root sign, it turns out that I can pull an x squared out 2 times. And remember that each time I have an x, so really what I'm saying is I've got x squared times x here, right? That's the x to the 5th part. And that means that I have a square root of a square, that those pull out as individual x's on the outside. So I'm going to have an x times x on the outside instead of x squared and x squared on the inside. So that leaves me then with 2 x's on the outside, leave some space here, and a single x on the inside, right? 2 x squareds form regular x's on the outside, single x on the inside to give me the oddball power. The same thing is going to happen with y then. If I have 2 pairs of y's that can pull out and a single y that's going to be left inside, that leaves me with a y squared on the outside and a single y on the inside. So there's the first 4 powers of y, and here's the last one, right? Because it's y squared times y squared on the inside, or just y times y on the outside. And then as far as z to the 8th power goes, it turns out that I can pull out 4 individual z squareds. So I would write that like this. And I don't have any oddball z's left on the inside. So that means I'm done with my expression. My answer is x squared, y squared, z to the 4th times the square root of xy. And that's how you do a problem whenever you have to combine the square roots using multiplication first. In the next video I'm going to talk about, actually I'm going to do cube roots next, okay? Deal with that one because I feel like number 12 is easier. And then we're going to come back and we're going to talk about number 5, which is kind of a doozy. So hopefully that makes sense. There's your second video.